All right, in this segment, we're going to work on factoring polynomials. Everything you've done so far, you've taken polynomials and you've multiplied them, maybe added and subtracted and put polynomials together. When you factor, you want to look to break polynomials back up into a product of their factors. You want to think of it as undoing multiplication. The first thing you always want to look at when you're factoring polynomials is to make sure they're in standard form. If you look at this first example right here, 2x minus 10, you want to make sure it is in standard form, and it is. You want to have it in descending order of exponents. The next most important thing is to always look for a greatest common factor. You want to look at each term in your polynomial and find the biggest thing that you can factor out of it. You're looking at numbers and letters, or variables if you want to call them that. For example, if you had the polynomial 2x minus 10, you want to look at their numbers first. You have 2 and 10. The biggest thing that you can get out of 2 and 10, of course, is a 2. You would also want to consider your letter x, or your variable, but since 10 does not have that x, the variable is not possible to be factored out. So you want to just keep it. Your greatest common factor here would be 2. If somebody said, what's the GCF for that polynomial right there, you would say the answer is just 2. However, when they ask you to factor it, you want to take that 2 out, and then you want to write what's left over if that 2 is taken out of each term. So if I had 2x, if I take 2 out of it, that's like saying 2x divided by 2 will leave you with an x. Minus, if you had 10, take 2 away, that's like saying 10 divided by 2 would leave you with 5. So the fully factored form of that polynomial would be 2 times x minus 5. We're looking for the greatest monomial factor that we can get out of each term there. When you're done, it's always a good idea to check. If you were to check here, you could say here 2 times x using the distributive property. 2 times x would give you 2x, minus 2 times 5 would give you 10. You also want to check, you know you're done. If you look in your parentheses here, if you've factored everything out of here you possibly can, you know you have fully factored your polynomial. If you look at this polynomial right here, this binomial x minus 5, there's nothing other than a 1 that we could factor out, so it would be fully factored. Let's take the second one right here. We have 9y cubed plus 3y squared. If you look at your numbers first, 9 and 3, the greatest common factor there, of course, would be a 3. Now this one also, each term happens to have a power of y. When you're looking at your variables, you want to look at exponents, and you can only factor out your lowest exponent. So the greatest common factor for our y's here would be y squared. So our GCF here would be 3y squared. If we take that out, if you take 3y squared out of 9y cubed, 9 divided by 3 would be 3. Y cubed divided by y squared would just be a y. So that'd be your remaining first term there. Plus, if you had 3 here, divide by 3 out here, you really have no number here. You could put a 1 if you like. If you had y squared, you took away y squared. So we really have nothing here, but we have to hold a spot, so we will have to put a 1 in there to hold that place. So if we check it again, 3 times 3 here would give us 9. Y squared times y would give us y cubed. Plus, we have to have this 1 here, so when we check it, 3y squared times 1 would give us the 3y squared we had back in our original polynomial. But that is truly fully factored again, because if you look in your parentheses here, you have nothing else to take out other than a 1. One more polynomial like this with a trinomial, if you had x cubed plus 4x squared plus 3x, you could consider your numbers first, your coefficients. If you look here, you have a 1, a 4, and a 3. So as far as coefficients goes, nothing you can really factor there. However, if you notice, each term has the variable x. So we could take out the lowest power of x. Remember, whenever you're doing a GCF with an exponent, you want to take out your lowest possible exponent of that variable. So that would be your x down here, or technically x to the first power. So that would be your greatest common factor. If you take that out, if you had x cubed divided by x, that would leave you with x squared. Plus, if you had 4x squared, take one of the x's away or divide it by x, you'd be left with 4x. Plus, if you had 3x, divide out that x, you would just be left with 3. Again, if you wanted to check, if you distribute here, x times x squared is x cubed, x times 4x is 4x squared, x times 3 would give you 3x. If you look in here, there's nothing else we could take out, okay? One other idea to consider when you're doing greatest common factors, a lot of times you're looking for monomial factors. It is possible for a GCF to be a binomial or greater. If you look at this last example here, we have 5x times x minus 2 plus 3 times x minus 2. You could consider your constants here, your coefficients, 5 and 3, but they don't have anything in common. We do have a single x out here, but no single x out here. But if you notice, both of them happen to have the binomial x minus 2. A binomial can be a greatest common factor as long as it's present in each and every term. So in our case here, x minus 2 would be our greatest common factor. If we pull out x minus 2, that's like taking x minus 2 away from each of these. So if I take x minus 2 away from my first term, I'm left with a 5x. Plus, if I take x minus 2 away from my second term, I'm left with just a 3. So my answer here would be x minus 2 times 5x plus 3. All right, so again, the first important thing is to look for your greatest common factors. Now, the second thing we want to talk about is just some beginning factoring of some trinomials. If you remember, when we multiplied two binomials, we always got a trinomial when you did multiplication of polynomials. So it stands to reason that when you factor a trinomial, you're going to factor it into two binomials. All right? So what you want to think here is we're going to do this in a little what you might call finding trial factors or using trial and error. So if we know that the product of two binomials is going to be a trinomial, we're going to say that if we factor these, we're going to get two binomials back. Okay? So what you want to look at here is to get your first term here, you want to look at how would you get n squared. The only way I could get n squared is to do n times n. Okay? No other way to get n squared other than do n times n. Then we want to look at our last term, and we want to ask ourselves, what factors of 21 would add up and make this middle term minus 10n? If you remember when you multiplied binomials, you did a method where you multiplied both parts of the binomial together, so you had an inner and outer product that should add up to negative 10n. So you got to think, what factors of 21 would add up to negative 10? The factors you would want would be 7 and 3. Now, if this last term right here is positive, both of the signs in your binomial are going to be the same. They're going to be the same as this middle term right here. So if we put in a minus here for each one, and we check it, n times n would be n squared. Minus 7 times minus 3 is plus 21. And when you check your middle product here, negative 7 times n is negative 7n. If I do these outer ones here, n times minus 3 would be minus 3n. That would add up to the negative 10n that I need here in the middle. So it would check, all right? So let's try another one. How about a second one here, y squared plus 3y minus 28. So again, we've got a trinomial. We want to try to factor it into its binomial factors, all right? So we want to set it up as two binomials first. Again, to get y squared, what we'd have to have in this first position here is we have to have a pair of y's. Now notice in this one that our last sign here is negative. That means that in your two binomials, you're going to have opposite signs. One of them is going to be a plus, one of them is going to be a minus. So you got to ask yourself again, what factors of 28 could add up and make a 3? The factors you would want there would be 7 and 4. Now to get negative 28, one of these has to be negative, but we have to be precise because we want them to add up to positive 3. So to get 7 and 4 to add up to a positive 3, we would want positive 7 and negative 4. So when you check it, your y times y is y squared. 7 times minus 4 is minus 28. And when you do your products for your binomials, you get a 7y with this inner product. With your outer product, you'll get a negative 4y. When you add those up, you'll get that 3y in the middle that you need. In our next segment, we will work on simplifying rational expressions.